What's up? Today we are talking about fraction word problems. We've been working a lot with fractions in my class, and we are working on word problems, and word problems can be a little scary, a little intimidating for a lot of students. I remember I used to feel like word problems were a little overwhelming because there's so much information to process all at once. But I will say this, is that the thing about word problems is the more you do them, the better you get at them. And you can develop really great strategies for solving them. Anyway, let's get to it. This is a fraction word problem that I gave my students this week. Let's read it. Miss Daniel's class and Mr. Hahn's class are collecting food for a charity drive. Miss Daniel's class filled 3/4 of a crate with food, and Mr. Hahn's class filled 2/3 of a crate with food. How many crates did Miss Daniel's and Mr. Hahn's class fill all together? Well, that was a lot of information. So the first thing I want to think about is, do I understand what the question is asking? And that might mean that I need to read the problem 2 or 3 or 4 or 5 times. Maybe I need to underline important information. And I always I tell my students, I'm like, figure out what the question is asking. Is it asking how much of something in total? How many times something in total? What fraction of something? Like, what is the question asking? And really what this question is asking is that there are crates, and we want to know with these crates, the total. Altogether means total. Miss Daniel and Mr. Hahn's class fill altogether. In total, how many crates were filled? Well, that can be a little challenging when it comes to fractions. So Miss Daniel's class filled 3/4 of a crate. So a crate means 3/4 of one crate. And Mr. Hahn's class filled 2/3 of a crate. I need to add these fractions up. And I usually use the butterfly method, which is when I add fractions with different denominators. I multiply the numerator and denominator. I get 9. And then I'm going to do the 4 times 2, which is 8. I'm going to add those up. My students know how to do this. 9 plus 8, well, that's 17. And then I multiply the denominators to get 12. So altogether, Miss Daniels and Mr. Hahn's class filled 17/12 of a crate. But wait a minute. 17/12. I'm looking at this number and I'm seeing that the numerator is greater than the denominator, which means this could also be a mixed number. And so I'm going to convert it to a mixed number. I know that by looking at it, we're going to have 1 5/12 crates. So you can I also with my students accept 17/12 crates. Don't forget to write crates. Now here's the thing. I was able to solve that fairly quickly, but not everyone, and I would say a lot of students aren't able to recognize that the operation that we need is addition. And so what I encourage students to do is to draw pictures. When you're not sure even, like let's say you're mostly sure, but you're not totally sure, draw pictures, underline information. So again, we're going to underline important information. Miss Daniel's class filled 3/4 of a crate. Mr. Hahn's class filled 2/3 of a crate. Let me draw a crate, or let's just say this is one crate. This is Miss Daniel's crate, and they filled 3/4 of it. And I'll write Miss Daniel's class filled 3/4 of this crate. But we've also got, and I'm not the best with drawing crates, by the way. This is Mr. Hahn's class, and they filled 2/3 of a crate. Actually, that's not very good. Oh, gosh. This question is asking me how many crates did they fill all together. And now, because I have this visual, I have this picture, I'm like, well, what I need to do is I need to combine these two crates, which means I need to add 3/4 of a crate plus 2/3 of a crate. And then I can move forward and say, okay, 3/4 plus 2/3 is going to give me the number of crates, and that number will go in there. We already know it's 1 5/12 or 17/12. Let's move on. Eddie practiced his violin for 2/3 of an hour on Saturday. He practiced his violin for 1/10 of an hour on Sunday. How many hours did Eddie practice his violin for on Saturday and Sunday? Now, I have some students read this problem and say, am I supposed to multiply or add? And this, again, is where pictures and diagrams and rereading the problem a few times come in handy. First of all, the question is saying how many hours total? How many hours did Eddie practice his violin for on Saturday and on Sunday? Let me think about this. Well, on Saturday, he practiced for 2/3 of an hour. On Sunday, Eddie practiced for 1/10 of an hour. And this question is saying, how many hours did Eddie practice for on both Saturday and Sunday? So I've written it out. I'm processing the information, and all I can think to myself is it makes the most sense to add, not multiply. I need to add 2/3 of an hour with 1/10 of an hour. Let's do it. Perhaps again using the butterfly method. Okay. 10 times 2 is 20. Plus 3 times 1 is 3. So we've got a numerator of 23. Multiply the denominators to get 30. And so there's my answer. My answer is 23/30 of an hour is how much Eddie practiced for on Saturday and Sunday. Okay, we've got one more problem. Let's take this to the finish line. Again, these are all from the worksheet 26.2 that I'm speaking to my class now that we did. So if you had trouble with it, hopefully this video will help you. Amy is a seamstress. A customer brings in a pair of pants that are 5.5 feet long, and he asks Amy to shorten the pants by taking 2/5 of a foot off the ends. How long will the pants be after Amy has shortened them? How long? How long means that we are looking to get an answer that involves length. Okay, well, let's say that this information, I'm reading this information and it feels very overwhelming. Am I supposed to add? Am I supposed to subtract? Am I supposed to multiply? I'm not sure. Guess what? I'm going to draw some pictures. Because that always, oops, not a very good picture of pants. That always helps me when I draw pictures. Even though I'm a terrible artist, it does help me when I draw pictures. Okay, here's a terribly drawn pair of pants. And what do I know about them? I know that they are currently 5.5 feet long. Actually, I don't even need to write long length. So this customer comes in and he wants to shorten the pants by taking 2/5 of a foot off. 2/5 of a foot off. Okay, shortening them means really subtracting. So I'm going to I'll make a dotted line, and I'll just say that's minus 2/5 feet, or minus 2/5 of a foot. As I'm looking at this, I realize I've got to do a subtraction operation here. And really, that means I have to take 5.5 feet minus 2/5 feet. And that's going to give me my answer. But wait a minute, I've got a mixed number here. So what I'm going to do to solve the problem is I'm going to take this mixed number and convert it into an improper fraction. An improper fraction is where the numerator is greater than the denominator, and it'll make it easier for me to subtract. So let's do it. First, I multiply 2 times 5, that's 10, and then I add 1, and that'll be 11. So now I have 11 halves, but I need to subtract 2 fifths. Okay, let's do the easy peasy butterfly method. 5 times 11, that's 55. Don't forget the minus. Sometimes people accidentally add, but it's minus right now. Minus 4, because 2 times 2 is 4. That gives me 51 on the numerator. 2 times 5 is 10. We multiply these. 10 is the denominator. 51 tenths of a foot is what we're dealing with. But I'm noticing that this is an improper fraction. I can convert it to a mixed number. And I happen to know, well, 10 goes into 51 5 times, but we'll have 1 left over. And if I'm not sure if that's correct, I can double check by doing 10 times 5, that's 50. Add 1, that's 51. So you can always double check. So I have 5 1/10 feet is how long the pants will be after Amy has shortened them. I hope this was helpful. We're going to keep working on it in my group anyway. And remember, practice makes progress. Until next time.